The front of the boiler was secured by a single bolt in the smoke box, but the rear fixings were not very convenient. With this in mind, I designed the fitment that you can see in this image. The plan was to secure the rear of the boiler with two bolts entered from the cab and screwing into the brass inserts in this new fixture. This was also to hold a D-type connector aligned with the coal hole. The connector was to mate with a cable carrying the motor and sound system wiring from the tender. This view inside the cab shows the two holes near the bottom of the boiler. Aligning and bolting in the new fixture was as difficult as fixing the gearbox, but once it was in place it made fitting the superstructure much easier since only 3 bolts were needed. When the superstructure was in place, the plate protecting the 140-tooth gear was rather obvious. Painting the lower part of it dull black made it disappear. Similar treatment was applied to the other side of the gearbox. Fitting the chain was quite straightforward. As expected, I needed to cut away part of the frame stretchers to obtain clearance. I added a strengthening strut above the rear one, but the other one was strong enough without a strut. I now needed to sort out the fit of the linkages and rods. As requested, Links had removed the pistons, valves and water pump, so those sources of friction were avoided. Being an electronics engineer, my plan was to run the motor and monitor motor current, which is proportional to torque, on an oscilloscope. More of this in the part on electronics. I fitted the rods and linkages in sequence while watching the oscilloscope for tight points and excessive friction. The principle worked well, but took a fair time and involved making some new parts and lots of work with needle files and shimming of the crosshead guide bars. However, eventually everything came together okay, and I was able to run the loco smoothly while it was suspended on the end supports. I decided not to refit the brakes. There was plenty of regenerative braking via the electronics and the motors, and a parking brake could be fitted on the riding truck. The brakes could easily have been fitted later with the dual pull rod system to avoid the chain, but I haven't bothered. The next step was to try out the chassis on the track. I was able to run the chassis up and down without problems. Power came from a car battery on a truck. Initially I operated from a cable and then multiple times under radio control. The remaining work on the superstructure was mainly cosmetic, but there were still a few structural issues left. Although the cab was connected to the boiler, it wasn't secure. I added 2 strong brackets to bolt the cab floor directly to the boiler. You can see a socket-headed bolt securing one of these just below the red reverser handwheel. Then there was the method of securing the smoke box door. It needed a better internal crossbar that could be removed easily to access the sound system. The one that I designed was held in place by small neodymium magnets. It attached to aluminium fittings that I glued behind the front flange of the smoke box with aldite epoxy resin. The fittings carried their own magnets. This was very positive and worked well. These type of magnets are very useful, and I use small disc versions to cover the lubrication holes in the rods and linkages and keep dirt out. While working in the smoke box, I decided the 2 steps below it were rather crude and decided to replace them with a single central step arrangement shown in most photos of Evening Star. You can see the result at the bottom of this photo below the smoke box. I didn't like the Winston buffers and decided to replace them. I had a photo of an actual Evening Star buffer, so I went to town on making 4 new ones. This included a ridiculous amount of effort on the buffer steps, which I initially machined as one part. Each face had a matrix of 32 holes drilled to hold the top parts of brass dressmaker pins Loctited in. My version is shown in this diagram. These 2 pictures show the final result. You may have noticed in my earlier photos that there was a fitting missing halfway down the boiler on the right hand side. There are 3 of these on a 9F, but I've been unable to discover their name or function. Perhaps a viewer will be able to enlighten me in the comments. I made a replacement out of brass. The Winston one had just been attached by a couple of drops of Loctite on the edges of the flanged part, which probably explains why it got lost. I decided to bolt mine onto the running board and use the same bolt to hold a small block to support a copper pipe coming from the cab end. Drilling the running board in place from underneath was difficult. To ensure the drill bit didn't slip, I pre-bored the small block and fixed it in place with araldite. This then acted as a drilling guide. I was worried that as the drill bit broke through, it would plunge on into the boiler cladding, so I cut off a length of tubing and slid it over the drill bit, so that only an appropriate length protruded. I don't know what the running boards are made of, but the material is extremely hard, and given the awkward drilling position, even using a new cobalt drill bit, it was surprisingly difficult. Once the hole was drilled, I put the fixture in place, marked through, and then took it away to drill and tap it at the appropriate angle. Since I was only using a single bolt, I put a small amount of araldite, not enough to squeeze out, on the bottom face before tightening up. This was to stop any possible later fitment rotation. It will need a touch of paint to hide the old Loctite. I spent rather a long time on this particular explanation, but it was deliberate to illustrate that in this project it was frequently more difficult and time-consuming to overcome poor assembly than to have started directly from the kit. However, that would have cost me a lot more. The cab was a bit sparse. I had plenty of photos of Evening Star when it visited Swindon, so initially I added a planked wooden floor and a checkered plate area and improved the linkages on the firebox doors. The group of 3 Winston pressure gauges had screws fitted from the back. As I'd come to expect, these screws were too long. Not wishing to disturb the assembly, I ground off the excess with a tungsten carbide bit in a Dremel. I had photos of the Evening Star pressure gauges, so I reduced them to size, punched them out, and covered them with thin plastic from a food pack before fitting them into the cavities of the Winston gauges. I also used some fine wet and dry to clean the paint off the edges of the gauges and reveal the brass. I spent more time than it warranted getting the reversing gearbox to work, especially since I decided to put the now non-functional valve gear lifting arm in a fixed compromised position, as per Hornby and all other electric 9Fs. This is the sketch I worked from while correcting it. The real Evening Star gearbox looked nothing like it, but I did rather like the red wheel and painted mine to match. I disconnected the redundant shaft to the chassis to simplify removing the superstructure and fitted a bearing under the running board to support a shortened shaft. The next video, part 4, will describe the track and its somewhat unconventional method of construction.